Hello students, now we are going to learn mathematic modeling of class 10th. Last lesson of the syllabus, mathematic model of class 10th. So this is the mathematic modeling of where this modeling we use, how it is useful for us. Let us see. Now presently the disease is spreading, that is corona disease. So this modeling will predict in how many days it will become 10 lakhs, in how many days it will become 50 lakhs. So like that, this modeling can predict what will be our scenario if we don't act now. So like that, it predicts everywhere. It predicts for monsoon, it predicts for all the other parameters. What will be the monsoon for next 10 years? It will also predict. So this is a mathematical modeling. This is called mathematical modeling. We will start with some simple modeling techniques, then we'll go for other. So mathematical modeling nothing but a mathematical description or a relation that describes some real life situation. Based on this, we can interpret the extent the solution is valid. Let us say, suppose interest is there, simple interest. If I deposit an amount in bank, what is the interest it is earning? We know PRT. So PNR by 100. So depending on that is a mathematical relation. A simple interest is equal to PNR by 100. There is a relation. Like growth of population, percentage of voter percentage, infant deaths, rainfall, disease spread, etc. All these things, you can convert them into a mathematical formulation and see that how the future can be seen. Suppose let us say example. 38 persons are going to a tour by hiring taxis. Each taxi can carry 5 persons. So excluding driver, how many taxis are required? It is a simple equation. 38 by 5, around 7.6. So there taxis are to be round number. So 8 taxis are there. Here what is the mathematical formula? Is n by 5. Number of taxis required is n by 5. N is the number of persons. So we can here to round it to next figure. So 8. This is simple. Suppose there are 500, so we'll put 500 by 5. So 100 taxis. Simple mathematical prediction. So we assumed here that all persons were same size and there is no double person or extra fat person. So these are some assumptions will be there in our mathematical model. Let us see a real life example here. Realize these are the 10 years data given that the percentage of girls joining the primary education. So 42% means around 58% boys are there, 42% girls are there. Here 56.5% boys are there, 43.5% girls are there. 2001 to 56 around 55.9% boys are there, 44.1% girls are there. So this is slightly increasing from 42 it became 44 for a period of 10 years. So then the point is when this will be 50%. I want by which year the girls will reach 50%. So one way of doing this, you find out the average. Go to next page. So change in 10 years is 44.1 minus 41.9. See, this is 44.1, this is 41.9. And I am directly doing minus. This is 2.2. So for 10 years, it has risen 2.2. That means per year it is rising 0.22 percentage. 0.22%. So for 50%, I want how much? 50 to 44.1 minus around 5.9. Further, it has to increase. So 5.9 divided by 0.22 is equal to 26.8 years. That means 27 years. So if we add 27 years from 2000 to 2001, we add 27 years, it will begin by 2028. My girls population in the school, primary school, is 50%. So this is math. What is here percentage? 41.9. 41.9 is the 10 years back. 41.9 plus 0.22 into n. This is the mathematical model. So 41.9 into 0.22 into 10. If I put 10, what is become? Plus 2.2. That is 44.1. So further it will continue. This is my modeling formula. I converted the situation by this data. This I am having past data. From the past data, the situation is converted to a mathematical formula. Now let us see. It can vary for 2 to 3 years. If I want exact period, then we'll do another way. This is X, 41.9, 42, 42.7, 42.9. This is the data given for each year. So when I am from this formula, if I apply this formula onto this, 41.9 plus 0.22 into 1 is 42.12. 41.99 plus 0.22 into 2 is equal to 42.34 into 3, 42.56. Like that, this is based on my this data, my equation. But the end it is equal, 44.1, 44.1. But in between, if you see the difference, you have a difference here. It has been really 42.6, but my formula says it should come to 42.12 only, but 0.48 more accorded actually. So this is the difference between the actual formula we have arrived and actual what happened. So this formula arrived based on 10th year and first year. So but this is difference. If I add this all difference, this is the difference, x minus x average. This is average. So x minus x average, if I say, this is as per formula, this is as per actual situation, there is a difference. So some of the values in the given formula are less than the actual values by 0.3%. You see somewhere, here it is 0.5%, 42.6, 42.1, 0.5% difference is there. Somewhere it is minus also. This is 1%, 0.1%, like that. So there is an error here. This can rise to difference about 3 to 5 years, since to increase per year is actually 1 to 2%. So we want to modify this formula. Let us say, but to modify this, to make it more accurate, I am changing the formula by what is the average, x minus x average by n. I am adding all these differences. X minus x original, this is as per formula. This is average. 0.22 is per year. This is average rise 0.22 per year. So every year I am adding 0.22, 0.22. So if the difference, if I am adding, this is the total. If I add all the difference together, then put by 10, I am getting 0.18 is the percentage error in this formula. So I have revised my formula. Mathematical model has been revised. This is P1 equal to 41.9 plus 0.22n plus 0.18. So this 0.18 is added to the model. So this my equation is further corrected to the actual scenario. Now I am deploying again here. This equation I am putting P1 value. This is P1 value. What is P1 value? 41.9 plus 0.22 into 1 plus 0.18. This is what. So when this is P1 value and this is my x value, when I do x minus P1, this is the original value, this is my new formula. When I do x minus P1, these are my differences. If you see differences, if we add all the differences, it will be 0, because this difference correction has already been corrected in the formula. When adding other differences, I'm having 0.18 into 10, 1.8 difference has come here. But here, my total difference is 0. Sigma x minus P1 is 0. So this is more accurate one. This is more accurate one than this formula. So like that, if we want to further, still there are differences. Here some minus is there, here some plus. Here also 0.3% is varying. Here also 0.36 is varying. So still there is varying. We want further nearer formula, then we will go for a standard deviation, variation. All these things will be added to the my formula and make it more accurate. So these at higher level we will do at inter and other levels. This standard deviation and or latest these all will be added in the formula, and we make a fine formula so that plus or minus 1 year we can come to what is the age. Within 50 years it will come. If you see with the new formula, it is coming 2027 itself. We are reaching 50% of girls. In old formula, we got 2028. So 1 year is reduced because my P1 has increased. So with the correction, I will assume that by 2027, 50% girls will be in the primary education. Once you further modify this formula, we may get exact figure, maybe 2026.3 years, like that. We don't. So the standard deviation is at a higher level. So all these things, this is the mathematic modeling. You see population growth, man-woman ratio, percentage going to higher education, spread of corona disease, monsoon prediction, oceans encroaching earth, ozone layer depletion, Earth's temperature, all these things we have mathematical formulas, scientists have made mathematical formulas, and we know from here, from 20 years later, what will be my ozone layer, what will be my the ozone, Arctic layer ice melting, what will be my earth temperature. All these things, the earth temperature can go up to 50 degrees. So they have made these models. So at our level, we simply go up to average by n. We rectify up to second level. So it can be further modified to other higher levels which you use in this. At a later stage, that will come. So what is the limitation of this mathematical modeling? It cannot predict the character of the people or certain aspects. It cannot predict. It can only give an idea and direction in which it is going. So, well, suppose I take another example. When two dice are thrown, sum of the disc appearing on top is. So, when two dice are thrown, first chance is 1, 1 is 2, or 1, 2, 3, 1, 3, 4, 1, 4, 4, 1, 5, 6, 1, 6 is 7. So, like that, we have the sum on the top. 6, 6 is 12. So, depending on the dice coming up, so I have 1, 1 only one chance. 1, 3 become 1, 2 and 2, 1. There are two chances. 4 can come 1, 3, 3, 1, 2, 2. There are three chances. Like that 7, 1, 6, 2, 5, 3, 4, 4, 3, like that 6 chances. So these are the probabilities of various sums. So this mathematical modeling says probability of odd sum is, let us say, what is the probability of odd sum? Odd sum is 3, 5, 7, 9, 11. I have to add the probabilities. 2 plus 4, 6 plus 6, 12 plus 6, 16 plus 2, 18. So this is half. 18 by 36 is half. So probability of odd sum is half. Probability of even sum is half. What is the probability of sum? 7. 7 is 6 by 36, 1 by 6. This is a maximum probability. Getting 7 is a maximum. Suppose we have to bet on getting 7. The other probabilities are less. Probability 6 is 5 by 36. So can you bet 1, 1? It is very less probability. Can you bet on 4? Sum 4. It is only 3 by 36 probability. 1 by 13 probability. But if you bet on 6 or 5 on 8, these three figures we can bet, we'll get maximum probability. So this is one of the model to give an example. So in future lessons in higher level education, all this modeling through this mathematic modeling there. Nowadays only Corona they have done this mathematic modeling. United States they have estimated long back. 3 months before itself, it's going to, they say the next month is going to touch 50 lakhs, something like. So based on mathematic modeling only, so that we can take a corrective action. Even environment also, mathematic modeling is going to take corrective action. So this modeling is useful for day to day. It's only touch given at this standard, how the modeling is being dealt, how we are going to predict future things. Okay, thank you.